Hello everyone, welcome to my channel. In this video, we are going to break down the UGC NET Computer Science previous paper of the year 2007 December paper 2. There are normally 50 questions here. We covered 25 questions, first 25 questions in the part 1, and this is the part 2. So if you have missed the part 1, please watch the part 2 and then watch the part 2 questions. I will explain complex concepts in simple terms and provide tips and tricks to help you answer them. So whether you are a beginner or an experienced one, this video is for you. So let's start the video. So the best known example of a metropolitan area network is a metropolitan area network is a computer network that interconnects users with computer resources in a geographical area or region larger than that covered by a large local area network, but smaller than the area covered by wide area network. The best example for metropolitan area network is cable television. Where the metropolitan, the name metropolitan means it covers a city or town. So option B is the correct answer. So whereas the FDDI means it is a set of ONSI and ISP standards for data transmission up to 200 kilometers. The FDDI protocol is used in the professional protocol. And Ethernet is a family of computer networking technologies using LANs and MANs. And IEEE 802.3 is a working group using wide Ethernet. Option B is correct. In a broadcast network, a layer that is often thin or non-existent is. In many broadcast networks, the presentation layer is either thin or non-existent because its functionality such as data formatting, encryption, compression is often handled by higher layers or isn't required at all. Option C is the right one. The maximum data rate of binary signals on a noiseless 3 kHz channel is. So given the options. So first of all, we must know what is the maximum data rate. The formula for the maximum data rate in a noiseless channel. So we have two types of channels, right? Noisy channels and noiseless channels. So noiseless channels it follows the Nyquist rate, and the noisy channels follows the Shannon's capacity. So according to the Nyquist formula for the maximum data rate of a noiseless channel, the formula is maximum data rate equals to 2 into bandwidth into log n base 2. So where n is equal to 2 for binary signals and bandwidth is 3 kHz written in the heads common 3 into 10 power 3, that is 3000 heads. Okay. So if you insert the values for the given formula, we will get the value 6000 bits per second. Similarly, for noisy channels, we have the formula bandwidth into log 1 plus 2 1 plus signal to noise ratio base 2. That is the formula for noisy channels, that is the Shannon capacity. Okay. So bandwidth into log base 2 1 plus signal to noise ratio, that is the formula for noisy channels. This is the formula for noiseless channels. This is the important thing. So option B is the right one. For pure Aloha, the maximum channel utilization is. So the maximum channel utilization rate for pure Aloha is 18.4% of the time for successful transmission. So option D is the correct one. An example of an adaptive routing algorithm is. So we have two types of routing algorithms, that is adaptive and non-adaptive routing algorithm. So adaptive routing algorithm is a routing algorithm that a router may select a new route for each packet in response to changing condition and topology of the network. So let us see what is in the adaptive and non-adaptive routing algorithms. So it will be helpful for you also for the further questions. Adaptive routing algorithms are designed to adjust to changes in the network such as traffic, link failures, topology changes. So adaptive means it will adapt to any condition in the network. Okay. The name it denotes that non-adaptive means it cannot adjust to the changes in the network. So it will follow strictly the basic rules. That means it will be static. Adaptive routing algorithm will be dynamic. So it will update based on the routing table dynamically. So examples of adaptive routing algorithms are distance vector routing algorithm, for example RIP protocol, link state routing algorithm, path vector routing algorithm. So these are the examples of adaptive routing algorithm. So option A is the correct one. So let us know something about non-adaptive routing algorithm also. So the non-adaptive routing algorithm is also known as static routing algorithm because they do not change their behavior based on the network conditions. And the routing table will be fixed and it will be set manually based on some set of rules. So here it doesn't respond to any network failures or changes dynamically. For example, flooding, selective flooding, shortest path routing. So these are all the non-adaptive routing algorithms. Next, in a two-pass compiler, during the first pass, what will happen? In a two-pass compiler, there are a two-pass. So in a two-pass compiler, during the first pass, user-defined address symbols are correlated with the binary equivalent. So option A is the correct one. A single instruction in an assembly language program contains. So a single instruction in an assembly language contains the one micro operation. So option B is the correct one. Transforming assembly language into machine code is the job of the assembler. Assembly language is converted into executable machine code by utility program referred to as an assembler. Assembly language may also be called symbolic machine code. The term derives from macro instruction and such expansions were originally used in generally assembly language code. Absolute loader demands that the programmer needs to know the start address of the available main memory. Absolute loader is a simple loader which performs loading process and needs to perform linking and program relocation process. It places absolute code into main memory beginning with the address assigned by the initial address assigned by the assembly. So it does absolute loader will do two tasks. That is, the programmer must know the start address of the available main memory and the linking to perform the linking. The top down parsers are predictive parsers because a predictive parser is a recursive descent parser that doesn't require backtracking. Predictive parsing is possible only for the class of LL of K grammars. So option A is the correct one. Next token of predicted. Next. In the context of compiler design, reduction in strength refers to. Reduction in strength in compiler design refers to an optimization technique where expensive or complex operations are replaced with cheaper or simpler ones. This often involves replacing higher cost operations like multiplication or division with lower cost ones like addition or bit shifting, thus improving the efficiency of the code. Option A is the correct one. How many states can a process be in? So normally a process can be in 5 states. That is a new state, create state, ready state, running state, waiting state or block state, and terminated or completed state. So these are the 5 states. Option D is the correct one. Next. A program has 5 virtual pages numbered from 0 to 4. If the pages are referenced in the order 0, 1, 2, 3, 0, 1, 4, 0, 1, 2, 3, 4 with 3 page frames. The total number of page faults with FIFO will be equal to. So here we are using the FIFO algorithm and we have some page frames here. Okay, so here the pages are referenced in the order. The order we are writing here 0, 1, 2, 0, 1, 2, 3, 0, 1, 4. So now we have 3 page frames here. So we load each and every page frame here from the secondary memory to the main memory. So only 3 page frames will be allowed here. So we are using the first in first out FIFO policy. So 0, next 0, 1 and 0, 1 and 2. So here we have the miss, right? So we are rounding up the values where there is miss. So we are newly writing any value, then we will round up that value. So here from the given so for the given pages, so which is the oldest one? So 0 is the oldest one. So we'll replace the 0 with 3. 3, 1, 2. Okay. Next. So from the given one, so which is the oldest one? So oldest one is 1. So we will replace the new page here with the oldest pair. So 3, 0, 2. Next. So from the so we have to replace the 1 value with the oldest pair, that is 2. So 3, 0, 1. Okay. So from the virtual page, we are replacing it in the main memory with the oldest page. So what is the oldest page here? 3 is the oldest page. So 3 is the oldest page. So 4, 0, 1. So we have the cache hit here in the 0 and 1. So we'll write the values as it is 401 and 401 because the values are already there available here, right? Next, 2. So we have to mention the 2 here with the, we have to replace it with the oldest page frame. So what is the oldest frame here? 0. So we'll replace the 2 in 2 with 0. So 4, 2, 1. Next. So what is the oldest page frame here? 1 is the oldest page frame. So we replace the 3 with 1. So 4, 2, 3. Next. So there is a cache hit here, right? So 4 is already available. So you write down the values as it is. So now, so where the page fault occurred in the FIFO page replacement policy. So 0, 1, 2, right? So 1, 2, 3, 4, 5, 7, 8 and 9. There are no totally 9 page faults here are there. So option D is the correct answer. Average process size equals to S bytes. Each page entry requires E bytes. The optimum page size is given by root 2 SE. So this formula is derived from the trade-off between the process size S and the size of each page entry E, aiming to minimize the total cost of memory management. The optimal page size occurs when this trade-off is balanced and the correct formula is root 2 SE. An example of a directory found in most Unix system is, it is a user. So in the directories, so we'll find the user here, right, in most Unix system. So the option A is the correct one. So user usually contains bytes for the largest share of data on a system. This is one of the most important directories in the system as it contains all the user binaries, their documentation, libraries, header files, etc. Next. The aging algorithm with A equals to 0.5 is used to predict runtimes. The previous 4 runs from oldest to most recent are 40, 20, 20 and 15 milliseconds. The prediction for the next time will be, so it will take all 4 previous runtimes into consideration. So here the prediction equals to A into most recent time plus 1 minus A into previous prediction, where A is the 0.5 used to predict the runtimes. So first of all, we need to find out the average of the previous runs. So that is 40 plus 20 plus 20 plus 15 milliseconds by 4. So average is 23.75 milliseconds. Now we apply the aging formula with A equals to 0.5 to predict the next runtime. So we already have some values here, oldest values, and we have to predict the next runtime here. Okay, so prediction equals to A is 0.5 into the most recent time, that is 15 plus 0.5 into 23.75 milliseconds, that is the average previous runs. Okay, so the most recent time, that is the last available runtime is 15, right? So this is the most recent time from the given 4 values. So 0.5 into 15 plus 0.5 into the average of the previous 4 runs equals to, so 25.375 milliseconds. So the prediction is approximately 25 milliseconds. So option B is the correct one. A major defect in waterfall model in software development is that. Option C is the major defect in waterfall model, that is a trial version is available only at the end of the project. Why? Because the waterfall model completely works in a fixed sequential manner, that is in a linear model. So that's why the end of the product will be available only at the end of the project. Function point metric of a software also depends on that. A function point is a unit of measurement to express the amount of business functionality an information system provides to a user. Function points are used to compute the functional size measurement of software. It depends on outputs, inputs, inquiries, internal files, and external interfaces. So here option C is the correct one. So number of external inputs and outputs. An error message produced by interactive system should have. So in general, every error message or warning produced by interactive system should have characteristics like describing the problem in language the user can understand, provide constructive advice for recovering from the error, the list of mistakes done by user, the message should not be non-judgmental. So here option B is the correct one. List of mistakes done by the user display. System development cost estimation with use case is problematic because estimating the cost of an existing system is always problematic because of the issues like technology factors, productivity factors, and cost factors. Option D, that is the data can be totally incorrect, is the correct answer. The approach to software testing is to design the test cases to analyze the design of sub-process in the software. So option C is the correct answer. Analyze the design of sub-process in software. Software testing is an investigation conducted to provide stakeholders with information about the quality of product or service under test. Test techniques include process of executing a program or application with the intent of finding software bugs and to verify that the software product is fit for use. Given a parallel algorithm A with computation time T If parallel algorithm A performs M computational operations, then P process can execute algorithm in time given by. So here the option C is the correct one. So this is the Brent's theorem. So this given theorem is called as the Brent's theorem. So the formula for Brent's theorem is 2P plus M minus C by T. So here T denotes the time required for the computation and M is the total number of computational operations, P is the number of processors, and the time is divided into two parts, that is the T with initial sequential computation time and the M minus T by P is the remaining operations here. It refers to implementation of different association mining algorithms. Identify the correct statement. So here FP growth. FP growth method was usually better than the best implementation of the a priori algorithm. FP growth is more efficient than a priori algorithm in many terms. In a priori algorithm, it occupies large space due to more candidates and hence execution time is more. Charm was also usually better than a priori. In some cases, charm was better than FP growth method. So option A is the correct one. Consider a typical mobile communication system. If 840 frequencies are available, how many can be used in a given cell? The cells are normally roughly circular, but they are easier to model as a hexagon. So here the cells will be in this format. So each cell will be in the format of a hexagon. So here they are grouped in unit of 7 cells. So there is a zero buffer about 2 cells wide where that frequency is not reused, providing for good separation and low interference. So here if there are 840 available frequencies and the system uses a frequency reuse pattern, typically the available frequencies are used in a neighboring cell. For a basic reuse factor, the frequencies can be divided by number of cells in a cluster. Assuming a 7-cell cluster reuse pattern, the number of frequencies per cell would be 840 by 7. That means it is equals to 120. So here 120 frequencies are typically available for each cell here in this scenario. But it seems the the option here is the option B, that is the 120 based on the standard reuse factor. Identify the incorrect statement from the given options. So here the internet has evolved into phenomenally successful e-commerce engine. E-business is synonymous with e-commerce. E-commerce model B2C, that is business to consumer, did not begin with the billboard where the e-commerce model G2C, government to consumer, began with billboard where. So from the given options, e-business is synonymous with the e-commerce. Option B is the incorrect statement here. E-commerce is narrower concept and restricted to buying and selling. E-business is a broad concept that involves market surveying, supply chain, logistic management, and using data mining. It is used in the context of business-to-business transactions, whereas the e-business can involve the use of internet, and external. So option B is the correct one. Identify the incorrect statement. So from the given options, option D is the correct one. ADN does not have application in non-ISDN environments where very high data rates are required. So it is developed as a sequel to BISDN. ATM is considered for non-ISDN environments where high data rates are required. So option D is the correct one. So this is about the all the questions in the UGC NET paper December 2007. I hope this video is helpful for you. Thanks for watching my video.